Hello, this video is on graphing inequalities for Honors Algebra 2 Trig. We have these examples that are in your notes sheet. You'll notice that these inequalities look very similar to lines. The only difference between them and lines, instead of having an equals to, we have a less than. Actually, in this case, a greater than or equal to, or a less than or equal to. And it's implying that we have more solutions than just the line itself. So we're going to first graph the top inequality. And so that's y is greater than 3x minus 1. So we can graph it very similar to the line, where it has a y-intercept of 1 and a slope of 3. Now all these points are on the line itself. The line represents when we are equal to the function. And so when both sides are the same. Now in this case it has the or equals to. And if it's the or equals to, we'll do a solid line. However, it's not just having solutions when y is equal to 3x minus 1, but also when y is greater than 3x minus 1. And in this direction are where all of the y's are greater than. We can go ahead and we can shade that represents all of the solutions to this inequality. Now, you can choose any point on here. For example, say it shows this point 0, 0. It's clearly on the upper portion of the line. So if you input 0, 0, it's going to give you a statement that is true. 0 is greater than or equal to 3 times 0 minus 1 is negative 1. So that shows that this portion over here is where the solutions lie, just like at the point 0, 0. Now we have another inequality. That's why it's a system of inequalities. That's when y is less than or equal to x. So we can graph the line y equals x. Excuse me. And it's when y is less than. In this case, it's going in this direction. And our overall solutions are where both inequalities intersect, this portion here. Now this portion of the graph out this way is where the one inequality is satisfied, but not the other. And this part where the purple and black were shaded before is where the first inequality was met, but not the second one also being satisfied. The answers are really just in this portion. Here with that blue shading. If you choose any point within there, it would satisfy both inequalities. For example, let's say we chose this point right here. This point appears to be negative 3, negative 1, 2, 3, 4, 5, negative 3, negative 5. If we input negative 3, negative 5 into both of these functions, you would see that you have negative 5 is greater than or equal to 3 times negative 3 minus 1, or negative 5 is greater than or equal to negative 10, which is true. So it would satisfy the first inequality. That would be good. And then, if you have the y is less than or equal to x, you have negative 5 is less than or equal to negative 3. Well, that's also true. So this has satisfied both of these inequalities. Now, if we look at the second one, we're going to graph the first inequality, which is y is less than negative 1/2 x plus 1. So we have the y-intercept, a slope of negative 1/2. Now in this situation, we are going to put a dashed line because unlike the other one, there is no or equals to. So we can dash this line. And you can either test a point to figure out which direction we can shade, or we can use some common sense here. This is when the y's are less than, so we're below. So in this direction is the direction that we would shade. And we also want when x is greater than or equal to negative 1. So x is equal to negative 1 would be a vertical line. because the or equals to will make it a solid line, and we want when the x's are greater. The x's are greater than -1, going this way. So we would shade where the overlap is, which is right here. This is representing the region of all of the solutions, the infinitely many solutions. Here in number 3, we have 3 equations. Some of them aren't in slope-intercept form. Matter of fact, if we look at this first one, we have it, well, it's almost in slope-intercept form. We can just divide both sides of the equation by 4 to actually get it there. So y is less than 1/2 x plus 2. The slope being 1/2. Because it's a less than, we could dash this line. And where y is less than is the portion down below. Now the second equation, or second inequality I should say, is x plus y is greater than 3. Now, since this is in standard form, I find it easier to find the x-intercept and the y-intercept. The x-intercept is 3, 0. The y-intercept is 0, 3. And do that by substituting 0 in for x, would create a y of 3, and y in as 0 would create an x of 3. It's an or equals to, so it's a solid line. And it's when x plus y is greater than 3. So you could go ahead and reason this out, or you could try to see which of the 2 sides of the green line has solutions. So I'm going to consider this point here 3, 3. If 3, 3 is a solution, we're going to be shading in that direction. If 3, 3 is not a solution, we can shade away from that direction. So 3 plus 3 is greater than or equal to 3. Well, that's a fact. 6 is greater than 3. So we are going to shade in this direction, or that direction is where the solutions are for the second inequality. Well, here also we have x is less than or equal to 2. Well, x equals 2 is this line here. And when x is less than, so it's this way, it looks like we get to just this little tiny spot right here where our solutions lie. Go ahead and start 4, 5, and 6 on your own. Pause, and then replay in order to see what the answers are.